Okay, guys, so this is our space cycles assessment, which includes lunar cycles, tides, and Earth movements, which also includes space seasons and day and night. We're going to be doing our corrections. Make sure that you are writing in a different colored ink or pencil. You can't write in blue, black, or gray. No regular pencils. Get something other than that. And again, for credit, you need to make sure that you're writing everything that we write on ours. And if you have any questions, please see your teacher, and again, write everything that we write. Number one, which diagram models a hypothetical situation in which every location on Earth would have 12 hours of daylight and 12 hours of darkness? So we're looking for a situation that would cause us to have equal number of day and equal number of nighttime hours. Well, I remember that in the summer, we have longer days and shorter nights. In fact, it's about 15 hours of daylight and about 9 hours of night. In the winter, we have the longer nights and short days. It's opposite. It's about 15 hours of night, 9 hours of day. And in the summer, we are, of course, tilted toward the sun. The winter, tilted away. So this has to do with the tilt, us being tilted either toward or away. But in the springtime and the fall is when we have equal night and day. It's 12 and 12. And so let's check and see which one would cause us to have a situation like the spring and not like summer or fall. The Earth orbits the sun in less than 365 days. That's not going to do anything for day and night. All that's going to do is have a shorter year. B says that the Earth orbits in a perfect circle. The orbit of the Earth doesn't have anything to do with the day or night. It's the rotation of the Earth and the fact that, again, we're tilted toward or away that affects the length of day or night. The Earth does not tilt. If the Earth doesn't tilt, then we would never have a situation where we would have longer days in the summer, shorter days in the winter. So that one I like, but let's just check the last one. Having two moons. Two moons would not affect day and night. That would only affect the tides. So C is our best answer. Okay, number two. The beginning of autumn in North America is in September, but the beginning of autumn in South America is in March. We already know this. It's opposite for each of the hemispheres. The diagram shows the positions of the Earth, the Moon, and the Sun one day in September and one day in March. Why does autumn start in different months of the year in North America and South America? Okay, so again, why does autumn start a different month of the year in North America and South America? We know that the fact that we're tilted either toward or away from the sun, like in the summertime and the wintertime, same thing in the fall and in the spring. The Earth does not orbit in a perfect circle. That orbit in the elliptical does not have anything to do with seasons or the fact that the North and South have different opposite seasons. North America has a larger landmass. Landmass isn't going to affect seasons. The moon has a greater pull. The moon only affects the tides, not the seasons. And the Earth's axis has a tilt. D, that is the only answer that makes any sense at all. And in fact, most of this was pretty much nonsense. We didn't even really need that information. Okay, number three. Which of these changes would likely occur if the rate of the Earth's rotation on its axis increased? So the rate of Earth's rotation, we know that rotation has to do with day and the night. It takes us, oh, yes, I'm sorry. Thank you. Good job waving, get my attention. Okay, which of these changes would likely occur if the rate increased? So the rate of rotation has everything to do with day and night. So let's check it out. The length of the seasons would be shorter. Seasons, nope. The seasons has to do with the tilt and the revolution around the sun, tilting and revolving around the sun. The length of the seasons would be longer. Again, that has to do with the tilt and the revolution around the sun. The length of the day would be shorter, okay? If we rotated faster, if we spun a little bit faster, then it would take us less than 24 hours to do one full rotation. So I like that one. The length would be longer. No, the length wouldn't be longer unless we slowed down. And so C is going to be our best answer. Number 4, which of the following best describes the moon phase and tides when the sun, moon, and the earth are positioned as shown below? We've got the moon, the earth, and the sun. That is going to be a full moon because the earth is in the middle. And we know that during the full moon, the moon is pulling the tides one way, the sun is pulling the other way. So we're going to have high tides and low tides. So it's a full moon, so it's either B or D. We can get rid of A and C. And we know that the higher highs and higher lows are your spring tides, so B is going to be our answer. Our neap tides are your weaker tides, and they occur during the first and third quarter moons. Okay, number 5. A student notices the moon is full one evening. Which sequence of moon phases will a student observe over the next 8 days? 8 days, so we've got a full moon. So if our sun is right here, here's our earth. We know the full moon is when the earth is in the middle. So over the next 8 days, here we have about 6 to 7 days of a waning gibbous moon. That takes about a week. And then when we get to a right angle with the earth, then we're going to come into the third quarter moon. The light's on the left, so that's going to be the third quarter. So over the next 8 days, we've got the full moon. That's the first on every one. After the full moon is the waning gibbous, not the new moon and not the waxing gibbous. So we can get rid of C and D. Then we have the third quarter. First quarter is not after the waning gibbous, so A is going to be our answer. Okay, number 6. A student draws the model shown below. Which of these best compares the conditions at location X? Here's X, and location Y. It is day at location X and night at Y. Nope, they're both on the same side of the earth, so they both would be experiencing daytime in that position. It is winter in X and summer in Y. Well, the X is tilted toward the toward the sun, so it would actually be summer in the X position and winter in the Y position, so it's opposite of that. There are more daylight hours at X than Y. Well, X is tilted toward and it's in summer, so it would have more daylight hours than the Y position. So I really like C, but let's check D. The moon is brighter when viewed from location X and Y. The moon looks the same no matter where you are on Earth because it has to do with where the moon is and its trip around the Earth, not where you are located on Earth. So C is going to be our best answer. Okay, number 7. A student wants to use a spinning basketball to model day and night cycles on Earth. Zoom in a little bit. That was small. Okay. What should the student do in order to best model the cause of day and night? Well, we know day and night has to do with the rotation and which side of the Earth is getting hit by the sun, right? So when we're being hit by the sun, it's daytime, and when we are not being hit by the sun, it is nighttime. So we spin the ball in different directions. It's already spinning, so the fact that it's already rotating, it's already showing that, so just changing the directions isn't going to improve this model at all. We're trying to improve it. The ball, tilt the ball while spinning. Okay, well, tilting would make it more accurate, but what does the tilt do? The tilt affects our seasons, not day and night necessarily, other than just the lengths of days and night, but that's not going to make this accurate model more accurate because it's about day and night, not about seasons. Paint one half of the ball black and the other half white. Well, that might kind of improve it, except that one half of the ball would always be in night, the other half would always be in day, and that's not accurate either. Shine a bright light on one side of the ball. So if we had a light shining, there's our light bulb shining on the ball, then that would kind of be our sun, and that would be the best way to improve this model to show day and night. All right, number 8. a student shows a model of Earth and the moon to a class. So here's our sun over here. There's the Earth and there's the moon. Which picture shows how the moon appears from Earth on the position shown? So if we're sitting on Earth, we know that this right here is the new moon. Always start with the new moon. That's the easiest one to identify. It's when the moon is between the sun and the Earth. We always go counterclockwise, so the moon following the new moon would be a waxing crescent moon. So we know the waxing crescent is the kind of crescent shaped or banana shaped. And we know the light is on the right. So the light is on the right. That is correct, but it is not a banana shape. That is a gibbous, not a crescent. B, we've got the light on the left. The light's on the left. The light on the left is incorrect. We need the light on the right. Waning gibbous, the light is on the left over here, and it's a gibbous. It's not a crescent. So here we have the light on the right. That's correct, and it is a crescent shape, so that's correct. So D is our best answer. Okay, number 9. In the summer, many people are going to enjoy the beach. The photographer shows a beach in Argentina, which is located in the southern hemisphere. So we know we're looking at the bottom half of the globe. That's where the southern hemisphere is. And which diagram shows the position of Earth when it's summer? We know during summer we're going to be tilted toward the sun. That's the only way for it to be summer. So here it's not tilted at all. So that's definitely not going to be summer in the south. Here we're tilted kind of away, kind of this way. It's hard to do on a 2D, but it's only this part is going. So the northern hemisphere is definitely getting more sunlight, so that's not it. Here we have the south tilted toward the sun. So this one I really like. This one we are definitely tilted away. So that would be winter in the south. So B is going to be our correct answer. And number 10, 2 friends want to go for a night hike when there is a full moon in July. If there is a third quarter moon on July 2nd, so July 2nd we have the third quarter moon, what is the approximate date of the next full moon? So the third quarter moon, so about 6 to 7 days later, so after the third quarter, we're going to have the waxing crescent, the waning crescent, and that's going to last for about 6 to 7 days until we get to the new moon. Then there would be a new moon on the 9th. Then again, after the new moon, we've got the waxing crescent. That's going to last about 6 to 7 days until we get to the first quarter. After the first quarter, we've got the waxing gibbous for another 6 to 7 days. So our full moon would be sometime around the 23rd or 24th, which means C would be our correct answer.